The last topic on acceptance sampling is called average outgoing quality. The terminology is kind of misleading because average outgoing quality is about the proportion of defective parts passing the inspection and getting into our inventory. Okay, so here is the situation. So you have lots coming in and you have a sampling plan. Then you use the sampling plan to either accept the lot or reject the lot. So when you accept the lot as is gets into our inventory. So there may be some very small percentage of defective parts in the lot. Now when you reject the lot, of course one option is to send the whole lot back to the vendor, in which case there is no average outgoing quality calculations. But if the option that you want to choose when you reject the lot is to do 100% inspection, assuming that that is feasible, and then remove all the bad parts and accept only the good ones. So that under that scenario, what is the proportion of bad parts that will get accepted in the long run? That is what this average outgoing quality is about, and the formula is given by this. P sub D is percentage of defectives in the lot, and for that percentage of defective in the lot, what is the corresponding probability of accepting the lot? And then the uppercase N is the lot size coming in, and the lowercase n is the sample size of the sampling plan. We don't know what the P sub D is going to be for a given lot. Therefore, like in the case of OC curve, we have to assume P sub D is, we have to make up values for P sub D ranging from 0 through say about 10% or so, and compute the AOQ for each of those P sub D values and then plot that. Okay, let's look at an example. So here is the condition under which we're going to look at AOQ, and we will look at that maximum AOQ in just a second, which is called AOQL. Okay, so here we have a sampling plan. The lot size is 1000. So determine the AOQ value for an incoming lot defective of 2%. So if P sub D is 2%, so first thing to do is to compute the corresponding P sub A from the Poisson table. So N times D is 2, and then go to the Poisson table. For 2 and C equal to 3, find P sub A. And then you plug it into this formula, and then you get your AOQ, average outgoing quality. Now you compute AOQ for a range of P sub Ds. And I have used 0 through 8% here. And then you plot that, and this is what the plot will look like. So the AOQ, the average percentage of defective parts that will get through, will climb as the P sub D increases, but beyond a certain level, more and more of the lots will get rejected and will be subjected to 100% inspection. So the average percentage of defective parts getting through will start to decline. So even though we will never know what the exact P sub D value is going to be for a given lot, we know that in the long run, whatever that P sub D value may be, this is the maximum possible value for the proportion of defective parts getting through the inspection and getting into our inventory. For that reason, this is called average outgoing quality limit, AOQL. Now let's compute the AOQ and find AOQL for this problem. So remember, the AOQ formula is P sub D times P sub A, n minus n over n. And we are assuming that the lot size is 1000. So if you want to compute only for 5%, then you can compute it. Okay, I'll compute it right here. So that will be 0.05 P sub D, and P sub A is 0.406 times 1000 minus 40 divided by 1000, and that number is 0.01949 or 1.949 Okay. If you do the same computation for the other P sub D's, then you get 0.901, 1.553, 1.908, 2.016, and 1.777, 1.553, 1.315, 1.086, and 0.879%. Now let's go ahead and plot these values. Okay, so we're going to plot. So this is AOQ, and we have P sub D here, because we start with 0 and 0. Okay. Next is for 1%, 0.901. So here we have 0.901 over there. And for 2% is 1.553. 3% is 1.908. For 4% it's 2.016. And then for 5% it is 1.949, and you can see that it starts to decline from this point onwards. Then 1.777, and then 1.553, 1.315, 1.086, and 0.879. So if you connect these, and then you see that's your AOQL. So the answer is for E, AOQL is for 4%, it is 2.016%. If we use n equal to 40, c equal to 1 sampling plan, no matter what the incoming defective percentages may be, on the average, the percentage defectives that will get through will never exceed 2.016%.